We do have a few people here so far, so that's good. So today we're gonna be looking at some basics, fundamental of Unity visual scripting, and then we will create a few scripts together, such as teleporting player, as well as synced buttons, and anything that else that would come up while we watch this. So we'll just watch this half an hour video, which is available on YouTube.
Welcome to our Unity's visual scripting tutorial. By the end of this video, you will know the basic coding principles and be familiar with the most commonly used nodes. Even if you never coded before, the first steps may be a tad confusing, but trust me, if you stick with it, you will get there in no time. If you played a bit with Unity before, but new to the world of coding, this guide is for you. We will cover many topics, such as data types, lifecycle events, logic, control flow, variables, collections, loops, and working with game objects. Unity 2021 and later comes with a visual scripting solution built in, so all that is left for us to do is to start working. In a new empty game object, or for any existing one, we add a script machine component. In the Add Component menu, select Visual Scripting, Script Machine. This component is responsible for running a script. At this point, change the source to Embed and click Edit Graph. The script graph window should show. Note that you can also open it through the menu window, Visual Scripting Graph. In this window, we can view and edit our script, a graph with nodes and connections representing the flow of command we provide to the computer. We already have 2 nodes, but how do we add new ones? Right-clicking on the grid will open the Fuzzy Finder, which organizes the various nodes by categories. If you already know the node we are looking for, or the component it belongs to, we can search for it. We can also open the Fuzzy Finder by dragging a line from the node's port and releasing the mouse. Right-clicking a node allows us to replace it, duplicate it, or delete it. Holding and dragging down while pressing Ctrl on Windows or Command on Mac will create a group, a handy way for organizing graphs. We construct a graph by connecting one node's output to another node's input. Connecting the green arrows will establish the order of execution for our graph to follow. The value ports are used to connect values. Each value port have a type that must be matched when connecting nodes. Nodes missing an input value will recolor the header orange. If the dim option is active, disconnected nodes will appear darker. Data types. Nodes representing single pieces of information. Data is the core of every script. In fact, all that computers do is manipulate and pass data. There are many data types available for us to use in Unity visual scripting, but we don't need to be familiar with all of them. The following are the most common ones. We have 2 types for representing numbers. Integer is a data type of number values, like 6, 10, and -9, commonly used for counting or ordering. It can represent both positive and negative numbers, but not number with a fraction, like 1.5 or 3.14. To represent these numbers with a fraction, we have the float data type, like 0.5, 7.0, or -2.4, primarily used for measuring. However, besides sorting both positive and negative numbers, it's not limited to fraction numbers only. It can also represent an integer-like value, such as 4.0. We mentioned we use number types for counting or measuring. In addition, we can also use them for arithmetic operations, like addition and division, or even comparing whether, for example, one number is greater than another. Boolean is a data type with only 2 possible values, either true or false. It can represent an object state, like whether a door is open or closed, or whether or not you gave this video a thumbs up. As we will later learn, we can leverage them to execute different sections of the graph's flow. A string is a variable length text, a sequence of characters like a name or a message. It can contain letters, numbers, symbols, and even emojis. We can use it to print messages to the debug console or display dynamic text in the game's UI. Enum, short for enumeration, is a data type consisting of a predefined set of values. For example, we can have an enum with gaming platforms. At any given moment, we can only select one of the predefined platforms to play with. Vectors are a group of 2, 3, or 4 float values. It can represent a character's position, speed of a moving object, the distance between objects, and more. Depending on the vector type, we can access its float component through the X, Y, Z, and W properties. For example, a vector tree consists of 3 floats, accessed through X, Y, and Z. Nodes may have input and output ports. Each accepts or provides a value of a specific data type. We can distinguish the port's data type by its icon. Primitive data types, like most of the types we discussed in this video, are represented with a circle, where each type is colored differently. Object data types, which are data types composed of multiple data types, are represented with an illustrative icon. For instance, a vector data type is displayed with colored arrows. Beside nodes ports, we can add a data type value in our script using a literal. In the fuzzy finder, we can search for the literal term of each data type to add it to the script, and then pass it as an input to another node. Lifecycle events. Nodes triggered by Unity that are usually the starting points of our script graphs. Like any game engine, Unity runs our game by executing a giant loop, repeating over and over to create and update each frame. With lifecycle events, we can tap into the game loop stages and apply our custom behaviors. We can also react to various stages of a game object. There are many events, such as input events and physics events. But for now, we'll focus on the lifecycle events. Those are the events executed during the object's appearance in the game. As you may have noticed, the event nodes are distinguished with a green strip. To help explain the differences between lifecycle events, I will use the debug log node. With this node, we can print messages to the Unity's console window. For example, this log will print hello in the console. The start function is called the first time an object appears in the game. This node is called only once for a given script graph. For example, here is the log node connected to the start event. Once we enter play mode, the game will print hello to the console one time. When it comes to rendering, a game is like an animation, where each animation frame is generated on the go. The update event runs for each frame that occurs while playing. It's the beating heart of our game, allowing us to adapt to the player in real time. In this example, we connect the log node to the update event. Once we enter play mode, the game will print hello to the console on every frame as long as we play. Fixed update is triggered 50 times a second in a specific interval. We use it instead of update when interacting with physics. Late update is similar to the update event, but is triggered after all update and fixed update events in all scripts. We can use late update when we want a camera to follow a moving object powered by an update event. On enable will be triggered every time the object is activated. For example, this may be used when a level is loaded, a game object is dynamically initiated, or reactivating a previously hidden object. On disable will be triggered when the object is deactivated. On destroy will be triggered immediately before an object is deleted or removed entirely from the level. We will learn how to compose logic for asking the game about the current state. What makes games unique compared to other entertainment mediums is their ability to adapt to their consumer in real time. Reacting to players' actions dictates the game to be aware of those actions and the rest of the game's state. When writing scripts, we can ask questions about the player's actions and the game state. After receiving answers, we can decide upon them. To compose questions, Unity's visual scripting offers us a handful of logic nodes. Each node provides a single output, a boolean. Let's say our game features a car. We can ask whether it has gas. Do we have its key? Is it broken? Etc. The building blocks for asking questions are comparing one thing to another. The fundamental comparison type is asking whether one thing is the same as another. In a car, if the remaining amount of gas in the tank is equal to 0 gallons, we are out of gas. Therefore, the car cannot drive. In a graph script, we have the equal and not equal nodes. Each receives two values and answer if they are the same. Those nodes accept any data type, including numbers, strings, booleans, vectors, and others. When we have two numbers, we can compare their values and ask whether one is greater than, or maybe less than, the other. If the car speed is above 55 miles per hour, we are exceeding the speed limit. In a script, we can use the greater and less nodes to compare numbers. We have the greater or equal node to ask if a value is at least some value, and the less or equal node to ask if a value is at most some value. If you want to ask multiple questions upon the same values, we can use the comparison node, which answers all the questions at once. Now that we have the basic building blocks, we can combine them into more complex questions. If a character owns a car and has a key, it can drive the car. We use the AND node to combine two questions, concluding if the answer to both is true. If a car is out of gas, or has a malfunction, it cannot continue driving. We can use the OR node to ask if either of the answers is true. One thing to note is that when we say either question is true, we don't mean that only one can be true. If we do want to limit to only one of the questions to be true, we have another node to accomplish it. Even if two characters own keys to the same car, it can only have one driver at once. We use the exclusive OR node to ask whether one and only one of the questions is true. We use the negate node to convert a positive boolean into a negative and vice versa. For example, the not equal node is just a shortcut for negating the equal node. We can combine multiple questions to ask even more complex questions. In fact, the exclusive OR node is an example of composing two questions. Now that we know how to ask questions and compose them into more complex queries, we can move on to make decisions based on the answers. The control flow nodes, together with the logic nodes, are the art of coding. They are used for decision making, guiding a script graph on dynamically executing gameplay based on the game's current state. When we speak about control flow in visual scripting, we refer to how our scripts are executed, when different actions are performed and in what order. We previously got to know data types, and that nodes have inputs and outputs of data values. We also briefly mentioned that nodes feature green arrows. Each arrow is a flow. When we connect an output flow to an input flow, we tell the script graph that after performing a node, it should move on and perform the connected node. We now know the two types of connections in our script graph: the control flow of execution order and the data flow of passing values around. The two flows are not dependent. A node can be used without the control flow. We can also pass the data flow to one node and the control flow to another node. We previously learned how events are the starting points of script graphs. Therefore, they feature only an output flow. They allow us to react to the player's actions, and in a few moments, we will see how we can utilize the control flow nodes to update our response to the player's actions dynamically, while taking the game state into account. But first, let's ask, when do we need dynamic decision making in our scripts? Let's say we want our character to unlock a door with a key. We only want the door to open when the character is holding the key. In this scenario, we have a condition, and we want to behave differently depending on the condition state. If the character lacks a key, the condition is not fulfilled. Otherwise, the condition is met. Let's see how we can implement this in a script. The if node uses a Boolean condition to determine which of the two output flows to execute. When the condition is true, it will do something. Otherwise, it will do something else. This node has two inputs, a flow and a boolean. It also has two flow outputs. This may be the first node you encounter that consists of more than one output flow. The control flow will continue to only one of the branches. According to the input condition, the node chooses a branch, one branch for a true value and another for a false value. Speaking of if you enjoyed this video, please hit the like button. The switch node is similar to the if node, but uses a value input instead of a boolean condition. As a result, this node can have more than just two branches of flow outputs. When we select a switch node, we can add, edit, and remove options in the graph inspector. Each option we add will create an additional output flow for the node. This switch node has a default flow output. It is used when the input value doesn't match any given option. The switch nodes come in three data type flavors: integer, string, and enum. We saw how switch nodes translate a value into one of the multiple flow branches. A select node, in contrast, maps such values into other data values instead of flows. Let's say we have a boolean. We can map it to 5 when it's true and 8 when it's false. A more advanced example will use select on integer. In the graph inspector, we can add a few options, say -2, 4, and 12. In the graph, we can then connect a different vector tree to each option. So now, when we pass one of the configured integer options, the node will provide us with a matching vector tree. It's essential always to provide input to the default port. In addition to boolean and integer inputs, there are also select versions for flow, string, and enum. Like a light switch that can turn a light on and off, we can use the toggle flow node to execute different branches, depending on whether the toggle is on or off. The on and off output flow will execute based on the current state. We can connect flows into the on and off inputs to change the state, or into the toggle input to flip it. Immediately after we switch a toggle, it will perform the turned on or off flows. And in any given point, we can determine the current state through the is-on output. Another form is the toggle value node. It's similar to the toggle flow in a sense that it has an on and off switch. Yet, instead of executing different flow branches, it will determine the output value based on the input on and off values provided. When the toggle is turned off, the output value will be whatever is connected to the off input and vice versa. When we use the onUpdate event node as our starting point, the flow will execute each and every frame. We can use the once node to limit the portion of the flow to run only one time, ignoring subsequent executions of the script. Using the after output, we can differentiate between the first and subsequent actions. Last, we can use the reset input flow to return the once flow. The last node is sequence. It will branch out the execution to multiple flows and perform them in order. It can be used for better organization and reliability by splitting a long flow. For a more advanced example, our first branch in the sequence can be interrupted and stop performing based on an if node. We can add another branch that will perform whether or not the first branch is executed entirely. In short, variables are containers that store information and values. A variable has a name, a type, and a value. The value inside the variable can change throughout the game. Imagine we have a cookie jar and an envelope. The cookie jar can contain different kinds of cookies, be it chocolate cookies or macaroons. An envelope, on the other hand, may only contain letters or postcards. Every container can contain any value as long as it shares the same data type. Therefore, we can't put a cookie inside an envelope. Well, we can try, but really, no one should. At any point, we can check which cookie is stored in the jar or replace it with another cookie. Each variable belongs to a single scope. We may want a variable to only be accessible on the current script graph, all scripts in the scene, or even remember its value after quitting the game. In Unity's visual scripting, there are 5 kinds of scopes: graph, object, scene, application, and save. Graph variables are local to the specific script graph. Therefore, they cannot be accessed or modified outside the script they are created in. Object variables are shared across all script graphs attached to a game object. Note that we can also edit object variables in the game object inspector. Scene variables are shared across all the script graphs in the current scene. We can also edit these scope variables in the inspector of the scene variable game object placed in the scene. This game object will be created by Unity. Application variables are accessible from any script graph. Their values remain even when the scene changes. However, they will reset once we quit the game. Saved variables will persist even after we quit and resume the game. Why should we use a small scope when one could use a larger access scope, like the application scope? There are many times when different objects will have similar variables. For example, health points. All enemies will have health points, but we need to differentiate each enemy's health separately, according to the damage they have taken. It can be confusing at first, but over time it will become evident which scope to use. To add a variable, we choose the relevant scope tab, name the variable, and press enter. We can now select the data type the variable will remember. Then we will fill an initial value. Under the Saved Scope tab, we have Initial and Saved subtabs. In the Initial tab, we define the values that will automatically be created for new games. In the Saved tab, we can see the state of saved variables for our current computer. In the graph, we can use the getVariable node to get the information stored in it. This node gives us the current value stored in the variable. Searching it at the fuzzy finder will present us with different scopes to select from. We can also change the scope at the nodes themselves. We get our variable by either typing its name or selecting it from the list. In this example, I have connected the getVariable node to the debug log node, which will print the variable's value to the console. We can also change the variable's value at any time by using the setVariable node. In this example, I have created a scene variable type that remembers a Boolean data type and set it to false. Collections are a group of items. Unity's visual scripting provides us two collection types: list and dictionary. A list is a collection of objects sharing the same data type. The items stored in the list are sequentially ordered, meaning that the order in which items are added is maintained. In the Blackboard inspector, create a new variable. At the type field, write down list and select which data type the list should store. We can now add as many values as we like to be part of the list. We can also create a list by code using the Create List node. A few nodes are available for adding items to the list. With the List Add Item node, we connect the list to the item we want to add. The item will be appended to the end of the list. If you want to add an item to a specific position in the list, we use the List Insert Item node. This node has a third input, index, which is the intended position. Note that the index starts counting from 0. Therefore, the first item's index will be 0, the second is 1, and so on. We can also replace an item at a given index position with another, using the setItem node. With the RemoveAt node, we can delete an item from the list using its position in the index. We use the Remove node to delete a provided item with its value instead of its index. The GetItem node, as its name suggests, retrieves the item stored at a given index. We can fetch the first and last items using the first item and the last item nodes. We can ask whether or not an item exists in a list using the Contains item node, providing it with a value. When we need to know how many items a list contains, we use the Count item node. Finally, the Clear node will remove all items from a list at once. Another collection is the dictionary, which allows us to map one value to another. When we create a dictionary, we need to specify which data type for an item's key and another data type for its value. When adding an item to the dictionary, we specify what key will map to it. For example, we may create a dictionary with a string for both the key and the value. Then, each item will have the person's name as a key and the person's home address for the value. We can then ask the dictionary what the address for a given name is. To managing dictionaries, we use similar nodes to those introduced for managing lists. Loops allow us to repeat a section of our script multiple times. Note that all iterations happen right away and will only stop when the condition is reached. The while loop node has a Boolean condition input and two flow outputs, body and exit. The node will execute the body flow repeatedly until the condition turns from true to false. At this point, the node will run the exit flow. When we can use a while loop, we may want an enemy to continue to chase the player as long as it's seeing it. However, once the player is out of view, the chasing loop is halted. With the for loop node, we can define how many repetitions the loop should go through. This node uses an index to count the loop's current iteration. The first number is the index initial value, and the last number is the index upper limit. We will only get up to the last number and quit the loop just before we reach it. The step will define the amount to increment the index after each iteration. An example for using a for loop is spawning a specific number of enemies, configuring each one with a different weapon based on the index value. The for each loop node iterates over a collections item. We pass in a list or a dictionary. The item outputs provides us with the loop's current iteration item. We may use this node to go to a list of the game's characters and move each one of them. We can also connect dictionaries to this node by toggling on the dictionary option. With the break loop node, we can exit a loop at any given time. Furthermore, we can use it for any loop by using it inside the body flow. The last part of this video is about working with Unity's game objects. A game object is any object that appears in our game scene, whether it's a character, tree, camera, or light. If it's in the scene, it's represented by a game object. Every game object contains components that define its properties and behavior. Adding components and tweaking their configuration differentiate between a character, a light, or a camera object. Since every game object is in the game scene, it has at least a transform component controlling its location in the world. When we want to refer to a game object, we can use the this node, which will provide us the game object that the script is attached to. We can also use the game object literal node to select a game object from the scene or a prefab asset. An inactive game object exists in the scene but isn't visible, nor does its or its components update. We may want to prepare a few enemies at our level and activate them progressively. To activate and deactivate a game object, we can use the setActive node, passing it an activity boolean. This is like manually unchecking the checkbox in the inspector. We have two nodes to ask whether a game object is active or not. getActiveSelf will tell us if the game object itself is marked as active, as in whether its inspector checkbox is ticked on or off. The getActiveInHierarchy node will check whether the game object is active and whether all of its parents are active. Usually, we use the hierarchy version as it's more practical. When making new game objects, we have two paths to choose from: duplicating an existing object or defining a new one. To duplicate an existing game object, we can use the instantiate node and pass it a scene game object or a prefab asset. Perfect for creating enemies in real time, shooting bullets, etc. We use the create game object node to create an empty game object while we play. We can also use the node variant with a name input to control the game object's name. The created game object is then available to us through the result output. We can use it to set the position or add new components using the add component node. Speaking of components, we can access a game object's component with the get component, passing the desired component type. We can also go the other way around. If we have access to components such as a collider, we can use the getGameObject node to retrieve the game object the component is attached to. Remove a component from a game object is achieved using the component destroy node. We can use the destroy node to remove a game object from the scene in real time, along with all its components and scripts. It's helpful if we defeat an enemy and now want to remove it from the world. In addition, we have a variant of destroy with time, which gives us the option to delay destroying the object. We can assign tags to game object to categorize them. For example, we may use collectible tag to define all items in the scene the players can collect. Tags aid us in identifying game objects to treat them differently in our scripts. In the Game Objects Inspector, we assign a tag in the drop-down near the name. We can either choose from Unity's predefined tags, or create a new one by choosing Add Tag and, well, add a new tag. We can use the Get Tag node to retrieve the Game Objects tag. We can assign a different tag to the game object with the Set Tag node. With the Compare Tag node, we can confirm if a Game Objects tag matches another. We can use the resulting boolean to run a script only on specific objects. To look up game objects with a specific tag in the scene, we got the Find Game Object with the Tag node. With this node, we can search for a game object in the scene by its tag. There are two variants for the node, one that returns the first matching object, and another that returns all objects with the assigned tag. We can also use the Find node to get a game object by its name. Thank you for following along. Unity's visual scripting provides us with tons of handy nodes to use, and while we did not cover all of them, you now got everything you need to know to start creating your own games. We will explore more nodes in the following videos, interacting with Unity's different systems such as physics, inputs, and more. Be sure to subscribe and let us know in the comments if there is anything in particular you are looking to learn about.
So yes, that video might be a little bit too heavy on toward the end, but don't worry. A lot of the stuff toward the end are more advanced, such as like game mechanics and stuff. So we don't really have to worry too much about it at the moment. So right now, what I would do is kind of show you guys some of the banter specific notes that is available in Visual Scripts, and we could try to create something together real quick. And once again, if you do want to look at the screen more closely, there is a tablet version of my screen available just by the front entrance. So you could grab that tablet. It's local, so so everyone would get their own, and so you could look at my screen closer. All right, so yeah, back to my thing. Let me just make sure. Okay, so yeah, as we have done the past few weeks, I'm not gonna do the whole SDK from the beginning. Once you have it all set up, download the SDK and all that. As always, there's a few things you do want to make sure that it's set correctly, and it might not set correctly until you restart the project sometimes. So those few things are, just to remind everyone, it's under Edit, Project Settings, and under the Players tab, you would want to find API Capability Level. Sometimes the Unity editor or the SDK itself would set it to .NET Standard 2.0, and that is incorrect. So you do want to make sure set to .NET Framework. Another thing is, in order for you to properly able to test stuff in play mode, you need to set the active input handling to both. Because by default, it would be in the input system package new, but we do need to use both. I think, yeah, these are the main things that you do need to keep an eye out for. And other than that, you should not have any issues building using the SDK after you set those settings. So, in order to get to our visual script graph, as I mentioned in the video, first thing you want to do is you could right-click in the hierarchy, create an empty, and I can just, let's say, we're going to create a teleport. So we will just name it teleport. this would be an enter, so our entrance, whichever. And what I usually get into the habit of is adding underscored vs. So then it would be a lot easier for me to quickly search for any items that has a script graph on it, or any items that has a script. So I can just search for underscored vs. It shows me everything that has a script on it. So that's kind of one trick of doing it. And then also, Eileen has shared a useful plugin. I think I share something useful. If you go to the Discord, oh, yeah, so right here. So yeah, so if you go to the share something useful channel and just search for Eileen, or just search for visual scripting, you would find this thing that Eileen shared to show VS script in hierarchy. So it basically adds that little icon beside your game object. So it's just a lot easier and quicker for you to see where all your scripts are. So I'm just gonna download this and add it to our project. And once again, I do apologize about my computer. It's been acting up again with all the Windows updates, so you just have to wait for this to load. And while that's loading, I'll go back to here. So we've created an empty game object. You could put it anywhere you want, or since this is a teleport entrance, I will probably add a box collider to it. So as you can see, if the player walks into this box, then they would get teleported. I can also, or you know what? Instead of doing this, I can just create a, let's just create a cube or a teleport. So now we have this. And in order for it to work as a teleport or or a trigger, you need to make sure that the box collider or any collider that it has, it's set to a trigger. And if you don't see the green lines, you could always turn off the mesh renderer. So as you can see, that's the exact trigger that we have. And I'll keep the mesh renderer so we know where the teleport is. So we'll just put that to the side here. And then what you want to do is add a new component, which is script machine. Just type script and you would see script machine right here. So in Unity Visual Scripting, there are two ways to basically host your scripts. You could use a graph, or you could embed it. It really depending on what you are trying to do, or what kind of mechanic this script is for. So since this is a teleport script and I could reuse it to make multiple different teleports to different area, instead of embedding the script, I can actually make it into a graph, and I'll just have to create a graph kind of a file right here. So I'll just call this my visual script or just VS. And I'll keep all my visual script graph in here. So in here, I'll just hit new. And then we have to go for this thing again with my Windows Explorer being buggy. Oh, Excel. Just excuse my computer.
It looks like you'll need to restart Explorer.
Yeah, I just have to wait it out. It doesn't matter if I go Control Alt Delete or Escape and close it, restart it. It does not. I need to reinstall my Windows. It's been a pain.
Try out Linux.
I am very tempted, but I don't know. Sebek's try using it, and there's so much stuff like he can't really use with Unity and stuff like that.
You
There's
can
still
run
some
Windows
issues,
in a virtual
basically.
machine on Linux. Yeah.
Yeah. But it's
Like
just gonna be
WinDocker
slow.
or WinBoat.
I just can't really make the switch to Linux yet. It's just there's the stuff that I do on Windows that is only available on Windows.
That's why I use WinBoat. It works really well to run the Windows-specific things in a virtual machine on Linux, sort of like their native application.
Okay, this is not well. Oh, there we go. At least this loaded. Okay, so we'll save our script graph under the VS folder. I like to keep things organized. I just name this the teleport. Okay, so yeah, so as you can see now, I have created a teleport scripts within here and calling it from this game object with the script machine. And like I said, you could also embed it, but that's only good if you if you're using that script for like one thing. If you're gonna like edit the scripts, it's only gonna be editing that one script that is embedded. So if I need to make changes, make updates to, let's say, multiple teleports at the same time, then a graph would be easier. So since I clicked out of it to embed, and now if I go switch back to graph, it's not going to find it, so I just have to reassign it. So now that's the graph. So when you click edit graph, you would be seeing this a lot. You will always see a on start nodes and on update nodes. And depending on what you're doing, you might not even need these two nodes. So for example, a teleport, we would not even need on start or on update. So we could delete those, highlight them, hit delete. And since this is a teleport, we do want to make it into an on player enter trigger. So, and this is where we'll be using some of the Banter specific Unity Visual Script nodes that are only part of the Banter SDK. So, how you could access those is by hitting right click on your inside your script graph. You see this pop-up menu, and from here on you could easily look through what's available that you could use. Let's say logic, so you have all these logic nodes. You could do math with all these nodes, and another thing is all the Banter specific nodes. So you go to Banter, They actually organize it somewhat now, so which is good. And you could look at under player. Actually, okay, actually no, not the player. Oh, okay, that's cool. So now you could actually set can crouch, stuff like that. Okay. Yeah, so as you can see, when I go into user, you can see there's a node called teleport to location. So that's actually what we need. So we'll add that node. You could also just search for teleport just by typing it in, and now you can see teleport location, set can teleport. But yeah, I think that's a different kind of teleport. That's like when you try to move around. And the teleport to location is actually a trigger that takes you somewhere. So we'll use that. And then another main one that we need to use is on enter trigger. So I could just type on enter. There is an on enter trigger, which is part of the base Unity, but there is also an on banter trigger enter events, which is actually better since it's banter specific. And I'll show you the reason why in a little bit. Because there's no on banter trigger exit node. For some reason, they did not include that. Let me just.
Maybe they have. It might have been 2 years since we actually looked last.
So yeah, so there's no on banter trigger exit for some reason, but there is on exit. On trigger exits. Should type trigger exit. That's physics though. That's not what we usually use. What's the other one? Yeah. Oh, it is the physics. Okay. So yeah, so on trigger exits. Yeah, so there's also on trigger exit, but which is a little bit more complicated to use. I'll show you guys in a bit. But for now, let's create this teleport. So we have this on banter, trigger enter, and also the teleport. And for this, it's actually very simple. You could basically just link the two. It's already telling it that, okay, if the player walks into this trigger here, it's gonna teleport put the player to this position. But the problem is the game does not know if it is yourself that walked into it or if it's somebody else walked into it, because the trigger's gonna be triggered as soon as something went into it. So you don't want that, because what happens is when one person walks into this trigger, it's gonna teleport everybody. So in order for it to know that, you only want to teleport the local player. As you can see, there's this user thing out here that you could click on and drag out, and you would be able to set what type of user. So you want to just do if the user is local. And then we will just do a if node here. So now what that means is this trigger would check for if the Banter user is a local user. And if that's yes, if it's true, then it teleports the person. Does that make sense? It's very simple. So the trigger, it's gonna check for if it is a local user that triggered the trigger. And this purple thing is a Boolean, so it tells the node that it's true. If it's true, then it teleports to the player. We could test it out real quick. So the position is 0, 0. We could also create an object. So we could get the position of the object as well. So we could do it under your variables. You could make a game object called exit. So this is the teleport exit. And it's a game object. So I'll just object. So now we can assign an exit position object. So what we could do is I could also just create it within this to keep it more organized. So I'll create an empty and I'll just name it teleport exit. And yeah, so currently it is at the same point, and I will just move it, let's say, over here, in front of this board here. So this is gonna be our exit. And we can also rotate it, so then when you exit, it's gonna be facing the proper rotation that you want. So what I would do is I'll go to local view for the rotation, and then I can just actually it will be better if I just do this. Yeah, so I can just rotate that. Oops, too much. Let's do maybe 180. Okay, yeah. So now when we walk into this teleport cube here, it's gonna exit us out, and the blue is gonna be the front, so we'll be facing this way once we come out. So we have made the object, and now how we gonna tell our teleport script that, okay, that's the exit. What we could do is in the object variable, you could assign that teleport exit to it, and now we can drag the variable into our script graph. So now it knows we have the game object of the teleport exit in the script. But now how do we tell that, okay, that's the position and whatnot? I think that's not gonna work because we need to get the vector first. We need to get thing. Double check on how I do. Okay, oh yeah, get position. Yeah, so we need to have the get position, transform get position, and transform get angular angles. That's for the rotation, basically. So we need those two things. So we could just type in transform, get position. Go. So now what we're doing now is taking this game object, the exit game object, plug that into the get position. So now we have the position of that particular game object, and plug that into the position. And now we will do the transform get angles, and that's to get the rotation of that same object. So I'll plug that in, and now we'll get the rotation vector. Plug that in. So now that's pretty much it for our teleport script. So now how we could test it, we could go back to our play mode, just hit the play. Hit yes whenever that pops up, just about the layer stuff.
I don't think I'm gonna be able to do it. Thing.
Yeah, earlier I was downloading the Eline. Oops, my Discord. I guess I did. Oh.
I'll catch you later. Okay, see you later.
Anyways. Okay. Okay, so now we're in our play mode. And the nice thing is in play mode, you could also keep your visual script graph on. And what happens is you would see that if I move my character inside that cube, you will see that it gets triggered. And then you could see the flow. There's like a little dot that would go through all these lines to the teleport, and then I'll be teleported. So let's see.
Bum bum bum.
Okay. So that's not working because Banter loco. Why is it not working? Check if player's loco is true. Yes. Why is it like that? So yeah, as you can see, it senses that I'm touching the cube. Oh, there you go. Oh, it did work. Okay, I just didn't walk into it properly. But yeah, I don't know why sometimes it like turns red, but it's actually working. So if I walk into it, let's see. Yeah, it does teleport me. So it is working. So whatever red, yeah, it's not actually
There's
true.
an exclamation point over there.
Yeah, it's interesting. It works sometimes. Oh, there you go. Yeah, and it could just be in play mode because play mode is not like 100% the same as runtime. So, but at least as you can see, if I walk into it, it does teleport me, and I'm facing the correct way. So that's working. Okay, any questions so far regarding to this teleporting scripts? You do, please do step up over here. I'll megaphone you. If not, we will continue to our next thing, which is a button, a sync button. So as you can see here in this sample scene here, there's already a lot of cool stuff you could dissect, basically. So like, let's say if you want to see how this little physical button works, you could always just click on it. And then since it has the underscore VS, you know, okay, there is a visual script in this object. You could hit edit graph, or usually it automatically opens up. And then you could study how this thing works. You could just like play around with it and all that. But right now, I'm just gonna, let's say, I'll make a button to turn on and off a particular object. So let's say this this kind of stage podium thingy, I wanted to basically disable and enable. And I can make a button for that. So what I would do now, I would just create another game object. I'll use a cube again. Put it right here, make it smaller. So now we have our button here. And in order for Banter to recognize an object that is part of the UI or a button or clickable, you do need to make sure that the layer is set to layer 5, which is UI. So set that cube to layer 5. I'll just name it button underscore VS. And you can also turn that into a trigger. It doesn't need to be a trigger in order for it to be a button. So the difference between a box collider trigger and box collider non-trigger is that if it's not a trigger, so if this is not checked, that means it has a collider on it. So you could actually walk over it or touch it with your hand. So I'll just keep that as a solid object. And it's still going to be clickable. And of course, I am going to add a script machine to it. And let's say since this is a button, I'm not going to be using it for anything else. I just want like this one button here. I can just use embed. So I have the script directly inside this cube, basically. And what I would do is, I would do it on banter click. On click, I think. Yeah, on click, it's part of the banter one. So whenever you see like these little colorful icons with BS on it, those are all banter specific nodes. So now I have on click for this. So that means itself. And I basically wanted to turn on and off this entire podium. So basically it's just this, clicking the check mark. So I can replicate that in our script. So I will do a toggle. Would be a toggle value. And it would start on. So let's see, we'll start off. So we'll turn, so the podium would be off to begin with. And what happens is on click, it will toggle it. and what is it turn so what I do is I put that on click node to toggle, and then I'm gonna tell it, okay, what happens when it turns on, and then what happens when it turns off. And that's very simple. So one way I can do the toggle is I could do set active, and I would it would already have one called game object set active. That's exactly what we need. So you put that in. There is a proper way of, well, not proper way, like there are multiple ways of doing this same thing. So what I would do is I will connect the turned on with the set active. And right now here I can just drag that whole podium thing down here, and it will know that, okay, when the button is turned on, it's gonna set and then value. I need to check it on, so it's basically the same as this little check mark here. So what it's doing is when I click on this button here, it toggles the thing to on, and when it's on, it's gonna set the podium game object as active. So that's one way of doing it. Or I can even just drag this whole thing, which is the podium game object, down here, and just have it as a game object itself like that, and I can plug those into here as well. I mean, it's the same regardless, because right now what I can do is I can duplicate the set active, but make that into set inactive. So I take out the check mark, and then I'll do off, and I can just plug that same game object. So now it knows whenever I click on this button here, it's gonna set the same game object to on or off. Or even one more way of doing it, I can go to the objects variable right over here. I can just set that to the podium game object, and then from the variable I can set that podium as the podium game object and drag that into the scene. So basically now when I just delete this game object here and plug these to it, it's gonna be exactly the same as earlier. But what this does is now from here on I can easily change this game object if I needed to. So if I decided, okay, that's not the one that I want to turn on and off now, I want something else, then I can just drag another thing into my variable, and now automatically I don't need to change my script. It already knows the new object is the one that is going to be turning on and off. So just undo that. So now I set back this podium object, and let's go in play mode and try it out. And I can also click on here so I can see my clicks when I turn it on and off. Okay, yeah, and the show VS thing is already downloaded. Okay, so and I'll show you guys how to use that in a sec. Okay, so now we're in play mode, and this is the button. So, yeah, theoretically, when I click on it, it should turn the stuff on and off, but it's not doing it. There. Oh, I think I know why. Because it has, yeah, this thing has a script on it. It probably doesn't like that. So let me. Yeah, because it has a join and everything. Script for me. Now let's try it again. So now when we click on this button, let's see what happens. Ah, there you go. Yeah, it works. So yeah, so as you can see, whenever I click on it, you can see that the flow has like those dots that goes through it, and it tells you, see, so when I click it on, the flow goes to the on one, and now because it knows that it's already on, when I click it again, it has the dots goes to the off. So now I have basically a button that toggles on and off that stage. But the problem is now is this is local, so any of these button clicks and everything, it does not actually get sent through the network to other players. So basically, if I'm in the scene with other people, I'm clicking it on and off, other people won't see that, only I would. So how am I gonna make this synced? There are multiple ways of doing it. You could use one shots. So what one shots does is basically sending a command when a user clicks on it, and that command would get automatically sent to everybody that are in the same world. But what happens if someone that comes in after? So let's say if I turn on the podium with one shot, and then somebody else comes into the world afterwards, then they won't actually see that podium because that commands to turn it on has not been triggered on their end. So a better way of making buttons would be using a feature called space state property, and that's a Banter specific thing as well. So we'll just edit our script here to work with space state property. So there are two main components of space state property. You could just right click and search for space state. And you should see these two Banter nodes, set space state property, and then this one on space state property changed. So we do need to use both of those. So let's get both of those on. So now I have space state property changed, and then set space state property. So what we could do now is by using the same logic where I have a toggle to toggle on and off the thing, but instead of using the turn off and on directly to turn on and off that podium object, we'll move those away for now, and I will use this toggle to toggle the space state property. So what I would do is I would put this over here, and I can name it podium toggle, and I can set value to on, just like so. And also you could see here it says it's public property. So what that does is if you uncheck it, that means it is a private property. So what that means is only a space admin or moderator would be able to click it. So anybody else that is not a space mod or admin, they won't be able to click the button. It won't change for other people, or it won't even change for themselves because it's not a public property. So which is good for if you have certain things like in this theater space here, I have all the admin buttons, which I can set the screen to different screens, stuff like that. Then only admins would be able to change it. But for this example, I'm just gonna keep it as public property, And I'll just duplicate this, and I'll create an off version. And it's case sensitive, so you do want to make sure you have all your case correct. And instead of using on and off, you could also use 1 and 0. It's more of a personal preference, but I'll just use on and off for here for the sake of clarity. And then same thing, I'll just plug the turn on to the set space state property podium toggle to on, and then also the off to the set the podium toggle to off. And now in here, this is where we actually change the podium. So what this node does is that it is an event listener. It listens to if a space state property has been changed. If it's been changed, then it sends the signal out. So we do need to make sure the space state property name is the same so it knows that's what that is. And now we'll do a compare string. So we could add a string lateral, and we will just do on for it. And we will do an if node. So now if oh yeah, equal. I also need an equal node. So now what it does is it's gonna check. Oh, sorry, 1 second. Let me restart it. Oh, there you go. Now I can see it. Can you guys still see the screen?
You are now streaming, that's what it says. Yes.
Oh, that's
Thank
weird.
you.
Why is it in?
Wait. Okay.
1 second.
Someone's pressed a button. Who's been playing with the buttons?
Sorry. It was cracking up, so I thought it'd be better on YouTube.
Okay.
My fault.
Okay,
It's
can you
okay.
guys see my screen again now?
Yeah.
Yes,
I see.
Yes.
Yeah, it's moving now.
Okay. Perfect. Thank you.
we're good.
So yeah, so back to the script graph here. So now we want to check to see if the value is equal to either on and off, right? So here I would just plug this in to if, and it's gonna check for if the new value is A equals to the value B. So now we plug this in here. So what that does is it's gonna check if the new value, which is either on and off, is it matching B. So B, I've set it to on. So if it's matching on, then it's gonna turn the podium on. So same thing, I would just bring this whole thing back. And now I can do the check where if the space state property value is on, is true, then it's true. And what you could also do is you could just plug the false into the off as well, so it knows when it changes. If it's off, then that means it's not on. That means it's false. Then it goes there directly. You could either do it that way, or if you really wanted, you could also just duplicate this whole thing and change this to off. And now it's gonna make sure that if the value is off, then it turns the podium off. It's basically the same as if I'm just gonna plug the false to there, but it's just like more clear to make sure it's not really necessary. So now we have a synced button because it is space state property. So for whoever that clicks on this button here, it's gonna toggle the space state property. and we can see that in action right now. So now we can see our button as well as our script. So you can see if I click on this button, you should see a line that goes in here. It would go to on, and then this would basically trigger this because that's also the on value, and then trigger it on. So let's see. So yep, so when I click on it, it's kind of hard to tell because it's so quick, but you can see all these little dots. So when I click on, dot goes up to here, it activates this, it's true, so it sets it on, and then when I click on it again, and as you can see, the line goes here, and then it activates this one and turns it off. So now when we actually put this into Banter, and when someone clicks it, everyone would see it synced. And the nice thing with Space State Property is, let's say if I turned it on and somebody else joins in afterwards, because the Space State Property is triggering it, so as soon as a new person joins in, the game would know, okay, that podium is supposed to be on, and it will turn that on for that new person as well. So this is how you make a sync button. All right, any questions regarding to that? If you do, feel free to walk up in front of me, and I'll megaphone you. All right, no questions so far. All right. So next, is there anything else you guys would like to try to do? So I can try to explain it. Features that you guys would try to create.
Move an object using
Yeah,
a
if you-
transform over time.
Okay, let me megaphone you 1 sec. So what was it, Pony?
I'd like to be able to move a game object using its transform over time so it moves smoothly.
Okay, so instead of using like an animation, you just want to use like
That's correct, yeah.
Okay. Let's see. On you for now. But why would you want to do that
That should be a
instead of using
challenge.
animation?
Because halfway through the transform, if I wish to move in a different direction, I can. Instead of having to play out the full animation, I can do multiple things.
Okay.
It'll make sense
makes
eventually.
sense. Okay. Yeah, well, let's try that. Let's transform an object that moves basically slowly, right? Or you know what? I'll
Yes.
show you guys one of my methods. It might work, might not work. We'll try it. Oh, before we do that, I have downloaded the thing that Eileen shared. So this show VS in hierarchy Unity package. So I basically went to the Discord. Yeah, it's under share something useful. Search for visual scripting, and basically adds these little icons for you, so you could know where all your scripts are. So I'll just open it, and then it will ask me to import it to my project. Just import it. And we might have to restart Unity after, we'll see. we'll just reopen the scene. Okay, so let me try save this first. Oh my god, take forever. Yeah, sorry guys, just have to wait for that. Okay. Okay, yeah, we do have to restart it, so give me one moment. Yeah, because right now, as you can see, all this stuff that has VS, it doesn't have that little icon yet. What I just installed would add an icon. So it's just easier for you to see where all your scripts are. And then while that's loading, let's try this. So it's Gemini. And the thing is, Bob has shared a Markdown document for visual scripting, specifically for Banter. So see if I can find it here. Okay, so yeah, as you can see here, I just searched for Bob Works visual scripting, and he made this visual scripting menu for AI. So what I can do is I can just copy this whole thing. And then I can let's try using Gemini. I paste that whole thing in. And then I can write my prompt. Copied stuff that are unneeded. 1 second. Okay. So now I can ask exactly what Pony was asking. So make a object. Transform its position. Uh, that's how you call it, lerp. For 30 seconds. Yeah, let's see if it's gonna give us something useful. So as make a game object using Unity Visual Scripting to transform its position with LARP over 30 seconds. And then I gave it the Banter Unity Visual Script menu that Bob has provided. So we'll just wait for it to see. Project is back on. And I was also using Pro mode, so that's why it's like a lot slower. But regular fast should also work. Okay, and as you can see, after restarting the project, you can see all these little icons to tell you where all the visual script graphs are. Yeah, so it gives you like a JSON format. I wonder if it could actually create the blocks for you. So let's see. Copy this block directly into your graphs JSON format. Yeah, because that would be very cool if actually creates the graph for me. Have anyone ever tried that?
No, it looks cool to me.
What was that, Pony?
I've never tried it, but it'd be cool if it would work.
Okay. Yeah, let's see. So scripting using JSON. Okay, so setup. Okay, it actually tells you. So minify the JSON if you're building directly into your asset. Be sure to stringify this JSON back in a single. Yeah, let's give that a try. So I need to make this thing into one line of text. It says you need to squash the entire JSON block. If you're in a single line of text, no line break, you could use free online JSON minifier such as this or code editor extension to do that. So we'll just follow his instructions to see if it works. this. That in. Okay, just like that. Create the .asset file. So open a text editor, copy and paste this wrapper into the blank document. Okay, so we copy this. And create a new .asset file. Try here. Floor, then we'll create one in here. There we go, and we'll edit this. Open with okay, so I paste this stuff in there, and then it says your single line JSON goes here. So we're gonna put that other script from here. Paste it in here. Yep, and then save it. Save and import, so save that to, okay, let's see. Yeah, so we have this visual script graph here, could not match. Okay, I need to rename it properly, so let's rename it to what it asked me to. Okay, and then, yep, so I name it properly, edit graph. Wow, would you look at that? So it actually created the entire graph for me, like without me having to actually, yeah, do anything with it. But we'll see if it works.
That's crazy.
Yeah, I'm surprised that actually worked. I mean, well, it created something, but now we'll see if it
Yeah,
works.
something.
So, yeah. So we can see if I, let's say, make a object here. Make a cylinder that moves around. And we will put that script we just made into there. So now I can find that same script, this one, drag that in. So now we have this graph connected to this, but we just need to make sure the variables are correct. Okay, so it's under graph variable. Oh, game object this. Yeah, so it has already done it. So we're just telling that we're using the game this itself. So we'll see if that works. We'll play. Oh, it has the start position and end position as well. So start from 0, ends at 10.
Hello.
What you doing?
Doing class
Audio coming.
from.
Ghost, you're loud. Okay.
I know. Sorry.
It's okay.
Okay.
You need to give it a
So
position
as you
to
can
move
see,
to.
it's
Well, no.
it's doing something,
It's doing
but I
something.
don't see it move yet. So start position, end position. There's an error here, so let's see what that is. Add component, script machine, yeah, and then drag to and hit play. Would you go ahead and okay? So okay, yeah. So if we go to our console, as you can see, yeah, it's been printing a bunch of errors. So missing input value for A. So I'll just basically copy this, give that to the AI. See what it does. Okay, so now it gave me a new JSON file. We'll try to use that. So same thing, add this to this site here. This one copy, paste this here. Copy this, and then we'll go back to our project. We'll open this again using our text editor. Okay, put this wrapper for the scripts, and then put the JSON in there. And then save it. So now if we go back to here and And look at our cylinder. It should have the updated scripts. Oh yeah, and it doesn't have that little error thing anymore. So let's see if it works. And why is the ad is depreciated? That's weird. Let's see. Yep, there you go. It's working. Yep, so it's moving from I think 0 to 10 in 30 seconds. Should stop. Yep, and now
Did it
30
stop?
seconds up. Now it's stopped at 10. Yeah, there you go. So it is working. And yeah, that's actually really cool. I have never really tried this way before, and now, yeah, it really unlocks a lot of possibility. You could just use an AI and get it to make the script for you. I didn't even have to make the script myself. So did that answer your question, Pony?
Yeah. Yes. I thought that was going to be a challenging one, but actually looking at the script, it's not that challenging anyway, is it, really?
Yeah, because I guess if you like look at it and try to understand it, it's basically using a time and times that by let's see, elapsed time and the duration, yeah, and then move the position using those. Yeah. And I think lerp is the key word, the key node that you need
Yeah.
to use and for it to actually do
Yeah.
the movement. Yeah. Or if you just use transform, it's just gonna like go from point A to point B.
Yes.
The LARP would have like
Yeah, I think
whatever
that's
in
my issue.
between.
Yeah,
Yeah.
just, yeah, lerp works.
All right.
That's
We
brilliant.
still have
Thank
about
you.
5 minutes to the end of the events. Does anybody else have any questions at all? Yeah, we were just basically touching the basics of visual scripting, but now we know that we could actually
I got
use
carried away.
AI to make your scripts. This is kind of a game changer.
That's crazy, isn't it?
Yeah.
It's amazing what Gemini could do then.
Well, it might even work with
Yeah.
ChatGPT as well. I'm not sure.
I
We
use
can
Gemini
try,
for
like,
loads of things, so that suits me.
Yeah. Just for fun.
I prefer Gemini over ChatGPT.
Yeah. Just for funsy, I will give it the exact same prompt to ChatGPT. See if it knows what to do. Okay, it does kind of create the same thing for me too. And it actually gave,
Apart
like,
from
it
that
puts
one's ready to
everything in
paste.
one line for
Yeah.
me already.
Yeah.
Does it work with Claude as well?
What, sorry?
Does it work with Claude as well?
Claude.
Yeah, it should
The most
be.
expensive
I
one.
don't have.
Oh, sorry.
Yeah, I don't have Claude. Well, because I mean the free one, like it is sometimes like, oh, your prompt is too long, blah blah blah. It's just like really picky with stuff, so I don't usually use
Yeah.
Claude.
Yeah, I
Okay.
agree.
But it
Claude's
should
a hassle
work.
to use unless you're paying for it, and it's too expensive.
But it has ethics.
But yeah, so now I created this. Let me just try to. I'll put the ChatGPT one as well in there to see if it works. Just name it the same. So I'll just go here, create a new text document. Dot assets. And then we will open this with a text editor and just paste everything that ChatGPT just gave me. Okay, save it. Okay, so here. Oh, okay, yeah, it's named different, so I need to name it ler position 30 seconds. Now, let's see. Blank. Okay, so whatever ChatGPT gave me, it's not working. Okay. Yep, so it does not
Just gotta
like
s-
whatever ChatGPT made because it's just blank.
got a start position. Maybe you could drop whatever ChatGPT gave you into that same little thing that Gemini gave you. See if it just adds it in. I don't
Well,
know.
Yeah, you mean the whatever minifier this thing?
No, it should already minify, isn't it? I mean, after that section, you dropped it into what was the next thing it asked you to do? I don't know.
Like drop it into an
Gemini
object.
gave
Yeah,
you
I did.
yeah, dropped it into that file, didn't it? A little file it gave you. Actually,
Yeah,
Yeah.
yeah. So I put it into an object, but yeah, it's still blank. So it's definitely it's not doing thing correctly. If I put the Gemini one back, it's yeah, it shows the script. So okay, well, so use Gemini,
Yes.
everybody.
yes.
Yep. Okay. Well, and that concludes our class today. Hopefully that helped any of you in any way. Yeah.
No, that was very cool.
Try and see what we'll do next week. Everyone for coming. So just a reminder, there is another event in an hour with CC. We'll see if she's here. Or else we do have the VR Late show at VR Chat later today, as well as some other events tomorrow with Center Stage in Banter, as well as Lean On Me is back tomorrow night in Banter as well. So check them out.
Thank you, Vanquisher.
very welcome.
That's brilliant.
Thanks for
And
coming.
the recording, I'll be posting.
Thanks,
I'll
Vanquisher.
put the recording up tomorrow.
Yeah, that would be great. Thank you so much for keep doing that, Barry. That's great.
Hey, Vanquisher,
Putting the-
do you think you could
Yes.
put make a little package with that script in it so I can kind of study the script and see how that all fits together?
Okay, the script that the AI just made.
Yeah.
Which script are you
yeah.
talking about? Okay, sure. Yeah, I can
thank
basically
you
yeah, my
much.
thing is still on, right? Yeah. I'll just
Yes, I was going to say the same thing. Because that was pretty damn cool.
Yeah.
Yeah.
And if you
absolutely.
could copy the prompt test as well. The prompt test text.
Yeah, so the so the whole prompt, right? Like this that I put earlier.
Yeah.
Is that the one?
Yeah.
Okay. So I will. Yeah, I'll link to the to Bob's thing, and then I will. Yeah, I'll post it all.
Cool.
Thank you
Oh,
so
that was
much.
cool. That was.
This was really
Excellent.
helpful.
That was. It was, yeah.
Yeah,
Yeah.
really helpful.
Glad.
Definitely.
Thank you.
For sure.
Yeah, it's been a few weeks since we've had these events that's catered for us guys. They've also been for building fresh worlds for the last month.
Oh my gosh.
What have you done? just notice why you've been sat down. You should have done that for back rooms, ain't you? Just to petrify
Man, I
people.
thought there was only
Yeah.
one leg.
Yeah, I did. Yeah, I used Mixamo for the legs.
Yes.
And I gave him a smiler face yet, but I used Mixamo, and it just kind of the back legs are just kind of drug around with it, but kind of works. I need to figure out how to make
So the person that says
spider
they
legs
don't
work.
like seeing spiders, and you said you won't bring spiders in, you turn yourself into a spider.
Yeah, no,
Spider legs.
there won't be any spiders. There's no spiders.
Spider legs don't really work with a humanoid avatar. Like Ravioli was pretty close with what he did, but
No, yeah.
it's still not even great.
Right. And I was actually going to ask him about how he did that. Yeah.
He basically weight
he
painted each
probably
leg.
manually.
Yeah, he weight painted each leg as
Yeah.
upper, and he alternated the left and the right ones. I'm pretty sure. So like the on the left
Right.
side, for example, it goes like left leg, then right leg, then left leg, and then on the other side it's the opposite.
Right.
So they
Constrained them to the. Yeah.
yeah. But it's also, they're all weight painted as upper legs, so that when he crouches, it goes into what people call attack pose, where all the legs come up and.
Yeah,
face towards you.
I've seen they
Yeah.
kind of face forward. Yeah.
Yeah. But you
Yeah.
sort of
This
have to do that.
I fed it through, and then I actually have a better model that I made that had the spider legs. The legs sat better and everything, and the hands were a little better. But I couldn't get Mixamo. Did not like it, and it would not. I think 'cause the legs were spread a little more. It did not. It would not.
Yeah.
Work for. It would not work for the walking animation at all. Yeah. This
We're
kind
going to
of
have to
does.
learn to do
It did
weight
bring 'em
painting
closer
ourselves.
I know. Yeah. Just have to start doing
Yeah.
more manual. Yeah.
Yeah.
Need to learn it, and then I can actually edit. Like the face is not weight painted right. If I crouch, the face gets all stretched. Funny. Yeah.
Yeah, it does, yeah. You don't notice too much because it's all in black, but
Yeah.
now I point it out, yeah.
Right. But I was curious if I could even get it to work, and it kind of does. Yeah.
Yeah, it's cool. It's very cool.
Yeah.
As long as that one doesn't glow in the dark, or maybe just the eyes. Yeah, then you'd be petrifying in the back
If I
rooms.
could just like you're talking about, get a emission mask for it and just do the
Yeah.
just do the light up face. Yeah.
Again, drop it in Gemini
Yeah.
and ask it
Go
to
in